Listen, what do you hear? If you're wearing earbuds, the sound you're hearing is made possible by a tiny, impossibly powerful magnet. When you put them away, listen to the satisfying magnetic snap as they click into their case. Now think about your day. Did you sit in a car? The small, silent motors that moved your electric seat, raised your windows, or even stabilized your airbag deployment, they all run on these same magnets.
This magic ingredient is everywhere. It is in the vibration of your smartphone. It's in the massive generators of wind turbines. It's in the guidance systems of an F-35 fighter jet and the sonar arrays of a Virginia-class submarine.
Modern civilization, our green energy future, and our national defense are all built upon a group of 17 obscure elements at the bottom of the periodic table, the rare earth elements. But here is the central paradox of our time, a strategic vulnerability so profound it keeps military planners and tech CEOs awake at night. The name Rare Earths is a lie. It is perhaps one of the most significant misnomers in history. These elements are not rare. Geologically, they're more common in the Earth's crust than copper, nickel, lead, or silver. The United States has massive world-class deposits. So do Australia, Brazil, and Vietnam. So why? Why does the entire modern world, our phones, our cars, our military, depend almost entirely on one single country for this critical resource? How did China execute a silent 40-year strategic checkmate, cornering a market that everyone else had but was unwilling or unable to keep? This isn't a story about geology. It's a story about foresight, economics, and a dirty secret the rest of the world chose to forget.
So, what are they? When we say rare earths, we're talking about 15 elements known as the lanthanides, that long, lonely row at the very bottom of the periodic table, plus 2 others that share their properties, scandium and yttrium. Their name is a historical accident. In 1787, a Swedish lieutenant and chemist named Carl Axel Arrhenius found an unusual black earth, an old word for ore, in a quarry in the village of Ytterby, Sweden. A Finnish chemist, Johann Gadolin, later analyzed this ore and isolated a new unknown element. It was rare because it was the first of its kind ever seen, and an earth because that's what they called the ore it came from. The name stuck.
The truth is, these elements are found diffusely across the globe. You won't find a pure vein of europium like you'd find a vein of gold. They are scattered, mixed together in ores at low concentrations. Their real power isn't in what they are, but in what they do to other materials. They are the magic pixie dust of modern metallurgy, chemistry, and physics. Add a tiny amount of them to an alloy, and they impart near supernatural properties. Add europium, and you get a brilliant, stable red color. It's what made the first color televisions possible. Add yttrium, and you get the red, plus applications in high-temperature superconductors and laser guidance. Add erbium to fiber optic cables, and it acts as a signal amplifier, allowing data to cross oceans without degrading. Add cerium, and you get a phenomenal catalyst. It's the key ingredient in catalytic converters that scrub your car's exhaust. It's also the world's best polishing agent, used to create the flawless, scratch-free finish on your smartphone screen and precision camera lenses.
But the king of them all, the one that changed the world, is neodymium. In 1984, scientists at General Motors and Sumitomo Special Metals independently discovered that by alloying neodymium with iron and boron, they could create the most powerful, lightweight, and heat-resistant permanent magnets known to man. These magnets are so powerful that they revolutionize efficiency and miniaturization. A conventional ferrite magnet would need to be the size of a brick to do the job of a neodymium magnet the size of a coin. Without them, the tiny, high-fidelity speakers in your earbuds would be the size of a coffee mug. The motor in your EV would be twice as large and half as efficient. The generator in a multi-megawatt wind turbine would be too heavy for its own tower. These elements aren't just materials. They are enablers. They are the invisible bedrock of the high-tech world. So if they are this magical and this common, why did the rest of the world surrender them? The answer lies in the second word of their name, Earth. Because they are never found pure, extracting them is a chemical and environmental nightmare. This is the dirty secret. Imagine you've just mined a ton of rare earth ore. Your job has barely begun. You have to crush that rock into a fine powder. Now the true nightmare starts. To extract those 17 elements, you must dissolve that powder in a horrifying cocktail of high-powered acids, sulfuric, nitric, and hydrochloric. This leaches the metals out. But here's the catch. Rare earths are chemical twins. They all have incredibly similar properties. They stick together. They refuse to be separated. The only way to separate them is through a brute force, mind-numbingly complex process called solvent extraction. You pump the acidic, metal-filled solution through hundreds, sometimes thousands of sequential tanks, each containing a different solvent and chemical agent. One set of tanks might pull out a bit of the cerium, the next set a bit of the lanthanum. This process is repeated over and over, stage after stage, until at the very end you might finally get 99.99% pure europium. It is complex, it is slow, it is expensive, and most of all, it is unbelievably, astonishingly toxic. For every 1 ton of rare earths you finally produce, you create up to 2,000 tons of toxic tailing waste. This waste is a sludge laced with a witch's brew of heavy metals, arsenic, lead, cadmium, chromium. And there's another even more sinister, dirty secret. The ores that contain rare earths almost always contain radioactive elements like thorium and uranium. Geologically, they form together. The acid bath doesn't care. It dissolves them too. So the waste sludge isn't just toxic, it's radioactive. You've taken a stable, low-level radioactive rock and turned it into thousands of tons of acidic, radioactive mud that can be easily spread by wind and water. You also create waste gas, including sulfur dioxide and sulfuric acid mist, and vast quantities of fluoride and ammonia-laced wastewater. And the carbon footprint? It's colossal. To produce 1 kilogram of neodymium, you emit more CO2 than producing a kilogram of steel, copper, nickel, and aluminum combined. The United States knew all of this. In the 1980s, the Mountain Pass mine in California was the world's #1 producer of rare earths.
It supplied the magnets for the first smart bombs and the red phosphors for the first color TVs. But then, environmental regulations tightened. The EPA, faced with the reality of this toxic radioactive sludge, imposed stricter and stricter rules. The cost of containment became astronomical. The mine's pipes leaked, spilling radioactive waste into the Mojave Desert. The company, Molycorp, couldn't keep up. It was cheaper to just buy the finished product from overseas. In 2002, Mountain Pass filed for bankruptcy and shut down. The West, in short, looked at this chemical, environmental, and radioactive nightmare and said, "No thank you. We chose clean air, clean water, and worker safety. We outsourced our dirty secret." And today, in a perfect, absurd symbol of this dependence, the resurrected Mountain Pass mine, the only one of its kind in North America, must mine its ore in California, crush it, and then ship all 50,000 tons of that raw concentrate 8,000 miles across the ocean to China. Why? Because that is the only place left on Earth with the industrial scale capacity to process it. We have forgotten how. As the West walked away, China sprinted toward the opportunity. This was not an accident, it was a strategy. In the 1980s, Chinese leader Deng Xiaoping issued a now famous declaration. "The Middle East has oil," he said. "China has rare earths." This was not a geological boast, it was a strategic blueprint. It was the starting gun for initiatives like Project 863, a state-funded push to master high-tech industries. China understood something the West forgot. You cannot be an industrial superpower without a secure supply of raw materials. They decided, as a matter of state policy, to become the world's refiner. This is Bayan Obo, Inner Mongolia. It is the rare earth capital of the world. It is also, by many accounts, one of the most polluted places on the planet. For decades, China's state-owned enterprises mined and processed rare earths with an intensity the world had never seen, and with environmental standards the West would never tolerate. The nearby city of Baotou became the capital of rare earths, but at a staggering cost. The byproducts of this industry were simply dumped. A massive, 6-mile-wide artificial lake was created. It is a tailing pond filled with a black, acidic, radioactive sludge. The air is thick with sulfur. Reports from the region have spoken of cancer villages, of livestock dying, of water that is undrinkable. By paying this staggering environmental and human price, China achieved its strategic goal. It could produce rare earths at a cost so low no one else could compete. This wasn't just capitalism. It was a state-backed industrial culling. China flooded the global market with cheap rare earth oxides, driving the price down so low that any emerging competitor, from Australia to the US, was suffocated in its crib. They couldn't just not compete on environmental standards, they couldn't even compete on price. Then, China deployed an even more sophisticated economic weapon: differential taxes. China placed high export taxes on raw rare earth materials, but it gave a large rebate to companies that exported finished products, like magnets. The message was clear: You can have our rare earths, but only if you move your factory here. It worked. One by one, American, Japanese, and European magnet manufacturers, including divisions of Hitachi and General Motors, closed their domestic plants and moved their operations to China to get access to the cheap, abundant, and subsidized materials. China didn't just capture the raw material, it captured the intellectual property, the metallurgical knowledge, and the entire manufacturing base that came with it. By the late 2000s, the checkmate was nearly complete. Then, in 2010, the trap sprung shut. Following a minor maritime dispute over a set of islands, China abruptly cut off all rare earth exports to Japan, a nation whose high-tech economy is utterly dependent on them. The world panicked. The price of neodymium shot up 800%. The price of dysprosium, a heavy rare earth needed to make magnets heat-resistant, skyrocketed 5,000%. Japanese tech companies, from Toyota to Panasonic, were paralyzed. It was a warning shot fired at the entire global economy. China had just shown the world that it had its hand on the off switch for every nation's tech industry. This story is a perfect example of how invisible supply chains control everything in our world. If you want to understand the real power struggles shaping your future, make sure you subscribe and hit the notification bell. You won't want to miss what we uncover next. The US, Japan, and the EU filed a case at the World Trade Organization, which they eventually won, forcing China to back down. But the message was sent. And China learned it no longer needed a clumsy embargo. It had perfected the value chain. Today, China mines about 70% of the world's raw rare earth ore. That's not the scary number. China processes 91% of the world's separated purified rare earths, and it manufactures over 92% of the world's high-performance rare earth magnets. The West doesn't just lack the mines. We lack the chemical plants, the metallurgists, and the magnet factories. We don't just have a mining problem, we have an everything problem. Fast forward to today, the world has changed. The US and China are locked in a great power competition, a tech war.
In a world of superpowers,
and the United States
two
has
giants
declared a
clash for
critical
dominance.
minerals crisis. Why? Look at our defense. The F-35 Lightning II fighter jet requires 920 pounds or 418 kilograms of rare earth materials for its advanced avionics, sensors, radars, and actuators. The Arleigh Burke-class destroyer, 5,200 pounds. The Virginia-class nuclear submarine, a staggering 9,200 pounds, or 4.6 tons of it. Every single gram of the material that underpins America's military supremacy is processed in and sourced from its primary geopolitical rival. This is the single greatest strategic vulnerability of the 21st century. And here is the supreme, almost cynical irony. The West is in a desperate, all-out race to fight climate change. We are pushing for a green transition built on electric vehicles and wind turbines. But this entire transition is hostage to China. You cannot build a high-efficiency wind turbine generator without neodymium magnets. You cannot build a compact, powerful EV motor without neodymium magnets. We are attempting to build our clean, green future using a supply chain controlled by the world's largest carbon emitter, using a process that is, itself, one of the most environmentally destructive on Earth. We didn't solve the pollution problem, we just moved it. We created a carbon loophole so large you could fly a cargo plane through it. And in doing so, we handed the keys to our future to another nation.
The weaponization is no longer theoretical. In 2023, when the US restricted advanced semiconductor chips to China, what did China do? It immediately imposed export restrictions on gallium and germanium. Why those? Gallium nitride, or GaN, is the critical material for next-generation radar, 5G, and advanced power electronics. Germanium is essential for fiber optics and military night vision. China was performing targeted, surgical strikes on the world's most advanced industries. And just months later, China played its ace. It banned the export of the technology to separate and process rare earths and the technology to make the magnets. It's no longer just guarding the materials, it's guarding the knowledge. China is no longer just the world's factory, it is the world's gatekeeper.
So no, rare earths were never rare. The name was a lie from the beginning. What is rare is a nation with the strategic foresight, the 4-decade patience, and the ruthless willingness to pay the staggering environmental and human price to control them. China's dominance wasn't geological luck. It was the result of a deliberate, patient, and brilliant industrial strategy. Today, the West is scrambling to catch up. The US, Australia, and Canada are spending billions to try and rebuild this entire toxic supply chain from scratch, this time with clean, modern standards. But it's a monumental task. They are 40 years behind, with none of the industrial base, none of the skilled workforce, and none of the tolerance for the cost, both in dollars and in their own backyards. As China locks down the technology and dominates the market, the question is no longer, can we rebuild it? The question is, have we even remembered how? And in this high-stakes race, is it already far, far too late? What do you think is the answer? Can the West ever break this dependence? Or is China's strategic checkmate already complete? Let us know your thoughts in the comments below.